Okay, in this video we're going to learn how to solve a quadratic equation by factoring. Now, you have solved quadratic equations before. The ones that we solved by square roots were called quadratic equations, but we didn't distribute them out. In this case now, if we have an x squared expression, that's what we call a quadratic equation. So this actually goes back to our factoring as well, because we factored with a lot of x squared terms as well. So, a little bit of vocabulary here. First of all, we have something called the zeros of a quadratic function, of a quadratic equation. So when we solve an equation, we get two answers. Those are called the zeros of the equation. So if you're asked to find the zeros, you're asked to solve for x. And here's why. Ha ha, pop quiz. Don't look at anybody else's paper, no texting anybody. Go, do these answers. All right. So did you figure out that 8 times 0 was 0, and then we had another 0 and another 0? Yeah, well, how come all those answers were 0? Well, if you said that you're always multiplying something by 0, you're correct. And exactly that. That's what we call the zero property of multiplication. And that says that if you multiply two or more numbers or two or more terms, two or more expressions, if they multiply to 0, then one of those must be equal to 0. So here's what it means. I have x times x plus 3. And I'm saying that that product, if I multiply those two and it equals 0, then one of those two, so either x equals 0 or x plus 3 equals 0. Notice that each of my factors are set equal to 0. And then if I solve that last one by subtracting 3 from both sides, I get that x is negative 3. So those are my zeros of that equation, x equals 0 and x equals negative 3. Let's try this first one here. We're going to be solving for x, so let's set each of our factors equal to 0. Let's take that expression, set it to 0, and let's take that expression and set equal to 0. Now, solve those two equations for x. Add 3 to both sides, so x equals 3. Subtract 4 from both sides, so x equals negative 4. So if we want to write our solution set, the answers to that equation is 3 and negative 4. Those are the zeros. Those are the x values. Can we do the same with the other one, the one on the right? Give it a shot. So we take our two factors and we set them equal to 0. And now we have to solve for x. So we'll start by maybe adding 5 to both sides over here. We get 2x equals 5. We'll divide by 2. And one of our answers is 5 over 2. If we solve the other one the same way, we get 2x equals negative 5. Dividing by 2, so x equals negative 5 over 2. Those are our two answers, positive and negative 5 over 2. Those are the zeros of the equation. So moving on a little bit, basically when we solve an equation, we want to look to factor the expression. So we're going to go back to our factoring for a minute. And then we're going to set those factors equal to 0, and we're going to solve them. So if I take this equation on the left, when I factor it, I go through my factoring methods. Let me see, is there a GCF here for x squared, for 7x, for 18? No, there's no GCF of those. So then I have to do my trinomial factoring. I'm thinking of two numbers that multiply to 18 and combine to give us 7. Let's see, did you think about a 9 and a 2 and maybe a negative 9 and a positive 2? So now we know what to do. That was step 1, we factored. Step 2, set each factor equal to 0 and solve. So we'll set both of those factors equal to 0. And at this point, you might be saying to yourself, well, these are kind of like easy equations to solve. I agree with you. As long as you write that equation down, then you can jump ahead and say x equals 9 and x equals negative 2. Although you might know it from the factors, please make sure you write the equations that are equal to 0. Let's go to the one on the right. I'm looking for a GCF, 9x squared minus 16, no GCF, but you probably recognize that 9x squared is a perfect square, and 16 is a perfect square. So if we factor 9x squared, it goes to 3x and 3x. 16 goes to a 4 and a 4, positive and negative. Here we go. We factored it, set the factors equal to 0. If we solve for x, we subtract 4 first, then we'll divide by 3. So we get an answer of negative 4/3. And I think you probably can guess what the other answer is going to be. We'll add 4 to both sides, divide by 3, and we get positive 4/3. Things are looking good. Things are looking good. So that works when it's equal to 0. But what do you think we should do if the equations are not set equal to 0? Well, if they're not set equal to 0, how about we make it equal 0? We like that. Let's make it equal to 0. And a little hint that I like here is to always keep my x squared term positive. So if I'm looking at this one on the left, I'm going to add 7x to both sides. Now remember, when we combine our like terms, on the left side of this equal sign, we don't really have like terms. So we just get x squared plus 7x, which is OK because we need an expression to factor. Is there a GCF? It looks like there is. Common factor is x. Let's set both our factors equal to 0. Here's one of them, and here's our other. Let's solve for x now. We know that x equals 0. Let's subtract 7. So our answers here are 0 and negative 7. Let's go to the one on the right now. I'm going to set equal to 0. And again, I want my x squared term positive. So I'm going to subtract 8x, and I'm going to subtract 33. I'm going to get my trinomial on the left side. X squared minus 8x minus 33 equals 0. See if you can solve that and find the answers. So we factor. Numbers that multiply to 33 are 11 and 3. And we can take an 11 and a 3 and make a negative 8 by making a negative 11 and positive 3. So again, let's write that equation that says that we're using that 0 property. And then if we can just jump to our answers of positive 11 and negative 3, we're in a good spot. Hopefully you got that one right. Let's try 2 more. It's not a 2 more. Oh, if you remember that movie, that would be great too. So, again, they're not set equal to 0. Let's set them equal to 0 and solve. See if you can solve the one on the left. Subtract 49. We don't have like terms. So 36x squared minus 49 equals 0. 2 terms, negative sign. That looks like a GCF to me. How about 6x minus 7? Or difference of squares. I said GCF. Haha, I lied. So if we solve both of these equations by adding 7 and then dividing by 6, one of our answers is positive 7 over 6. And can you tell what the other answer is going to be? You just might be able to. If we subtract 7 from both sides and then divide both sides by 6, positive or negative 7/6. If you want to write your answer as plus or minus 7 over 6, oh, that's cool. Can you try our last one? So you subtracted 5 from both sides. Okay, this is one of those tricky ones where we got to break up the middle. I multiply my 2 and my 5. I'm looking for factors of 10 that can make a 9. How about 10 and 1? So let's split that up. 2x squared minus 10x plus 1x minus 5 still equals 0. I'm just going to bring that equals 0 down for a minute. We split it. Let's get a 2x times x minus 5, and then a plus 1 times x minus 5. Bring down that equals 0. So the expression that I've just factored is 2x plus 1 times x minus 5. All that factoring is old stuff. So here's the new stuff now. Set them equal to 0. 2x plus 1 equals 0. X minus 5 equals 0. If I subtract 1 and divide by 2, one of my answers is negative 1/2. And then if I add 5 to both sides, I get x equals 5. So now let's combine our factoring in order to solve a quadratic equation. Set it equal to 0, factor it, and then use our zero property of multiplication.